sklearnutilsparallel. Description: the sklearnutilsparallel module provides tools for parallelizing computationally intensive tasks within scikit-learn. This allows for significant performance improvements, especially when dealing with large datasets or complex models. Inputs: njobs. This parameter controls the level of parallelism. It specifies the number of jobs to run in parallel. If set to -1, it uses all available processes. If set to 1, it runs sequentially. Verbose. This parameter controls the verbosity of the output. Higher values indicate more detailed logging. Outputs: results. The results of the parallel computation, typically in the form of a list or a dictionary. Elapsed time: the total time taken for the parallel execution. Steps: initialization. The parallel backend is initialized based on the provided njobs parameter. Task division: the input data or task is divided into smaller units that can be executed independently. Parallel execution: the subtasks are executed in parallel using the chosen backend. Result collection: the results from each parallel job are collected and aggregated. Metrics: runtime measures the total time taken for the parallel computation. Speedup compares the execution time with a sequential implementation to assess the performance. Improvement: visualization plots. Parallel execution timeline: a visual representation of the parallel execution, showing the start and end times of each subtask. Fine-tune parameters. Njobs: optimizing the number of parallel jobs can significantly impact performance. Experimenting with different values is crucial for finding the optimal setting. Backend: selecting the appropriate backend for the parallel computation can impact performance in resource utilization. Available backends include low-key, threading, and multiprocessing. Uncertainty methods. Non-parallelization typically focuses on efficiency rather than uncertainty estimation. The underlying algorithms used within the parallelized tasks might have their own uncertainty. Methods. Challenges and fixes. Challenge 1: overheads associated with parallel execution. Sample use case: running a parallelized task on a small dataset where the overhead of parallelization exceeds the gains from parallel execution. Fixes: adjust the njobs parameter to a smaller value, or switch to a sequential execution for small tasks. Challenge 2: memory limitations. Running large number of parallel tasks can exceed available memory. Sample use case: parallelizing a process that requires substantial memory for each parallel job, leading to memory exhaustion. Fixes: reduce the number of parallel jobs njobs. Use memory-efficient algorithms or data structures, or utilize a machine with more memory. Challenge 3: inter-process communication. Overheads. Communication between parallel processes can be costly, especially in distributed settings. Sample use case: frequent data exchange between processes in a distributed parallelization setup. Fixes: minimize data exchange by processing data locally or using efficient communication protocols.